In this episode, we're going to take what you learned about malware behavior and static features and use it to answer a bigger intelligence question that stakeholders care about a lot. How wide is this activity, and what does that scope imply for risk and response? Campaign reach is about understanding whether you are looking at an isolated event or part of a broader coordinated effort, and whether the same operator or toolkit is showing up across multiple targets, time windows, or infrastructure sets. Beginners often assume campaign reach is something you only learn from big public reports, but you can reason about reach in a disciplined way using malware metadata and the relationships it reveals. Malware metadata is essentially descriptive information about a sample and its characteristics, and it can provide pivot points that connect one artifact to other artifacts. The danger is that metadata can produce an overwhelming web of associations. So the key here is to pivot with intent and validate links so you do not inflate reach through coincidence. By the end, you should understand how to use malware metadata as a map-making tool, how to avoid common pitfalls, and how to communicate reach with calibrated confidence. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A good starting point is to clarify what we mean by malware metadata, because the word can sound like a grab bag of technical details. Malware metadata includes the descriptive attributes and derived characteristics that help you identify, compare, and cluster malware artifacts. Some metadata is highly specific, like file hashes that identify an exact sample, and some is more general, like structural characteristics or repeated configuration patterns. Some metadata reflects how the sample was built, such as compilation characteristics or embedded resources, while other metadata reflects how it might be controlled, such as configuration references to infrastructure. Metadata matters because it creates join points, which are places where one artifact can be linked to others in a way that might reveal reuse and coordination. Beginners sometimes treat metadata as trivia, but in campaign analysis, metadata is often the glue that connects isolated observations into a wider view. The discipline is to treat metadata-derived links as evidence, weigh their strength, and use them to test hypotheses about reach rather than to produce impressive but fragile maps. To think about campaign reach properly, you need to distinguish reach from impact, because they are related but not the same. Reach is about breadth, meaning how many systems, organizations, or environments are touched by the same activity or tooling, while impact is about what happens within a given environment. A campaign can have wide reach but low impact in many places if it is mostly scanning or probing, while a campaign can have narrow reach but extremely high impact if it targets a specific victim deeply. Beginners sometimes assume that wide reach automatically means high severity, but in intelligence, you want to communicate reach as one dimension that informs risk and prioritization. You also want to avoid the opposite mistake of assuming that if you only see one case internally, the campaign must be limited. Limited visibility can make reach appear smaller than it is. A disciplined approach treats reach as an estimate based on evidence, with clear uncertainty and clear assumptions about what might be unseen. Pivoting on malware metadata begins with choosing pivots that are likely to travel, meaning they are likely to connect related samples without being so common that they generate meaningless noise. An exact hash is a precise pivot that confirms sameness, but it is brittle across variants, so it is useful for linking identical samples, but not for mapping an evolving campaign. More general pivots include consistent configuration structure, recurring embedded resources, repeated string patterns, or consistent build characteristics that suggest a shared development pipeline. The goal is to find a pivot that is discriminating enough to suggest relationship, but not so narrow that it only finds one sample. Beginners often choose pivots based on what is easiest to notice rather than what is most meaningful, which can lead to either overbroad associations or no useful associations at all. A disciplined pivot choice begins with your hypothesis about what kind of campaign you might be dealing with and what kind of reuse would be plausible. Then you choose metadata pivots that would be expected if that hypothesis is true. Once you choose a pivot, validation becomes critical because metadata pivots can link samples that are not truly related. Shared tooling is a common reason for false linkage because multiple actors can use the same packers, the same libraries, or the same general build environments, producing similar static characteristics. If you pivot on a feature that is widely used, you will find many samples that share it, but that does not mean they belong to the same campaign. This is where feature sets matter because one shared feature is often weak, but multiple converging features can be more discriminating. Validation also means checking for independence, asking whether the linked samples truly share multiple independent characteristics or whether the apparent similarity is derived from one shared component. Beginners often get excited by a single strong-looking match, but professional reach analysis requires you to be skeptical and to look for corroboration. When you validate carefully, your reach estimates become more defensible and less likely to be inflated by coincidence. A powerful way metadata supports campaign reach is by connecting malware artifacts to infrastructure, because that can reveal operational reuse across time. If a sample's configuration or embedded references point to certain domains or endpoints, that can provide pivot points into infrastructure clusters. Even if infrastructure rotates, historical context can reveal patterns of reuse, and those patterns can suggest a broader campaign footprint. The disciplined move is to treat infrastructure references as time-bounded evidence and to avoid assuming that a reference domain is still active or still controlled by the same operator. You also need to consider that infrastructure references can be decoys or outdated configurations, especially in reused toolkits. This is why you combine infrastructure pivots with behavioral observations when possible, because behavior can confirm whether a referenced resource was actually used. When infrastructure and metadata align, you gain a stronger case that multiple samples belong to a coordinated operation. That alignment is one of the best ways to move from sample-level analysis to campaign-level insight. Another key to understanding reach is to look for patterns of reuse that indicate campaign scale, such as recurring configuration structures that appear across multiple samples over time. A campaign that persists often reveals a consistent operational style, like a repeated way of embedding configuration, a repeated method of communicating, or a repeated set of functional modules. These patterns can travel even when specific domains and hashes change, because they reflect how the operator builds and deploys tooling. Beginners sometimes focus on the most visible artifact, like a domain or a hash, and miss the deeper pattern that actually indicates continuity. When you pivot on these deeper patterns, you can find a family of related artifacts that represent an evolving campaign rather than a single static sample. This is where reach analysis becomes more realistic, because real campaigns often evolve. The discipline is to continuously test whether the pattern truly indicates common control or whether it could be explained by shared public tooling. When you do that, you can describe reach as a range with supporting evidence rather than as a single overconfident number. Campaign reach analysis also benefits from distinguishing between core artifacts and peripheral artifacts. Core artifacts are those that share the strongest and most discriminating features, suggesting they are closely related and likely part of the same operational set. Peripheral artifacts may share only one or two weaker features, suggesting possible relationship but requiring more validation. Beginners often treat everything found through a pivot as equally related, which inflates reach and creates fragile narratives. A disciplined approach treats reach as a layered concept, where you might have high confidence in a core cluster and lower confidence in the broader boundary. This layered view allows you to communicate reach honestly, saying that a central set of samples appears strongly related, while additional artifacts may be related but require further confirmation. It also guides your next collection steps, because you can target validation efforts at the boundary cases that would expand or shrink your reach estimate. This is a professional way to manage uncertainty while still providing useful scope insight. Communicating campaign reach requires careful confidence language, because reach can be misunderstood as certainty if you present it as a definitive map. A disciplined communication approach explains what the reach assessment is based on, such as shared metadata patterns, infrastructure references, and observed behaviors, and it explains what limitations exist, such as possible shared tooling and incomplete visibility. You also want to avoid implying attribution unless evidence truly supports it, because campaign reach is about coordination and scope, not necessarily about naming an actor. Beginners sometimes feel that the story is incomplete unless they name who did it, but many reach decisions can be made without that. For example, you can recommend increased monitoring or targeted checks based on a cluster of related samples, even if attribution remains uncertain. The key is to make your confidence proportional to evidence and to describe what would change your assessment, such as discovering additional correlated artifacts or disproving a key metadata link. When you communicate reach this way, stakeholders can act with appropriate urgency without being misled by overconfidence. A common pitfall in reach analysis is turning pivoting into an endless search for more related artifacts, because the idea of mapping a campaign can feel like it should always be expanded. The disciplined approach sets stopping points based on decision value, such as reaching enough confidence to decide whether the campaign is isolated or broader, or identifying enough of a core cluster to guide monitoring and response priorities. Another pitfall is assuming that absence of found relationships means limited reach, when it could simply reflect limited data sources or limited visibility. This is why you should be explicit about what your reach estimate is conditioned on, such as the datasets and evidence streams you currently have. A third pitfall is confusing similarity with coordination, because two samples can be similar due to shared tooling without being part of the same campaign. The defense against all these pitfalls is the same discipline you have practiced: intent-driven pivots, validation, independent corroboration, and calibrated confidence. Reach is valuable only when it is defensible. To close, pivoting on malware metadata for campaign reach is the practice of using descriptive features and patterns to connect artifacts, define clusters, and estimate scope in a way that supports decisions. You start by choosing metadata pivots that travel well and are discriminating. Then you validate links to avoid false associations driven by common tooling. You use feature sets and convergence across evidence streams, especially when metadata aligns with infrastructure and behavior, to build a more credible campaign picture. You distinguish core clusters from peripheral possibilities, treat reach as a layered assessment with uncertainty, and communicate clearly what evidence supports the scope and what could change it. When done with discipline, reach analysis turns isolated malware observations into broader intelligence that helps teams prioritize, coordinate, and understand risk without exaggeration. This episode also completes the sequence you were building, because you can now move from indicators to pivots, from pivots to clusters, and from clusters to campaign-level understanding with a workflow that remains defensible from start to finish.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.